you very much for the introduction, Rob, and good afternoon, ladies and gentlemen. My colleague Klaus and myself are really pleased to be here today to present about Coperion's energy-saving and low-maintenance retrofit solution for pneumatic conveying of highly abrasive materials in the cement industry. And that's by using our state-of-the-art wear protection DuroProtect rotary valves. So we'd like to take you really on a short journey about our experiences, and we will give you a quick overview of the company. We'll keep that very short, I promise. We'll be focusing on the fundamentals of a pneumatic conveying system, with a focus on the feeding device itself. So we'll be really particular on one part of the pneumatic conveying system. We will introduce the DuroProtect rotary valve concept, as well as its advantages as a feeding device. Most importantly, we'll focus on 2 or 3 references in the cement industry that we have in place over the last 10 years, before analysing some of those references with a complete ROI calculation based on realised projects across the world. And then finally, we'll wrap up with a short conclusion, just summarising the benefits for our end user. So I won't focus on this slide too much, but basically it's just to show the organisation and structure of Coperion. You can look back to your notes after more details, but basically pre-2000, some people in the cement industry may have known us by the company Beschler. Now with Coperion, part of the Hildebrand Incorporation. So Coperion has production centres in Germany, India, China and the USA, mainly focusing on their local markets. We're a leading manufacturer of key components in the cement industry, as well as the wider minerals industry. Rotary valves, diverter valves, slide gate valves, these are all in-house components, and we use these as well through our systems engineering department to supply complete process solutions for pneumatic conveying systems, which is what we'll focus on today. Just a bit about the R&D side of the business. We have test labs again across the world in similar locations, where we're able to test various modes of conveying, low pressure, high pressure. In Germany we have an 800 metre conveying test distance rig for our testing purposes, so we're able to take your product and try it over long distances. And we have installed references of 200 tonnes an hour conveying capacity, and that's now increased as well. I think it's up to maybe 250. We have an archive of over 14,000 product samples, so we can call upon previous experiences, whether that may be raw meal, cement, GGBS, fly ash, whatever the product. We have laboratories that can do a fast analysis of the product, characterisation of wear behaviours, so we're able to select the right technology for the project. Klaus will explain a bit more on this shortly. 30 locations worldwide, 10 manufacturing facilities, about 2,500 employees, 10,000 installed bulk materials handling references across Europe and the world, of which 1,500 are in the minerals industry. On top of the 1,500 system references, we have approximately 10,000 installed components. As the components have been in the minerals industry since 1970, the DuroProtect concept, which Klaus will talk about shortly, came in 2007, kind of in conjunction with our unique ceramic rotary wear protection design. And I'll hand over to Klaus now for the interesting bit.
Good afternoon from my side. The pneumatic conveying system with the recommended feeding device, especially the rotary valve. You have different samples for them. You have for the rotary valves, you have a low space requirement, low maintenance expenses for this rotary valve, a long time running, high operation reliability and operation safeties. The rotary valves are gas and dust tight to the atmosphere. Feeding devices, we have examples, a screw pump. I think it's very well known in the cement industry. We have these pressure vessels for long distance conveying, but you see the height of this machine, and you have the rotary valve. This is it's a bigger one, but the height is very less in relation of the other tools. Yeah. High degree of availability and a long service life is only possible with an effective rear protection concept. This concept takes into account the product characteristics like particle size and the motion hardness, but also the operating conditions like conveying pressure and the distance of this conveying. Here it's shown executions of the different DuroProtect steps. On the left side, the standard execution. This means standard. This means there's no ear protection, but this is a cast iron housing without any ear protection. Later on, we have the steps: DuroProtect 1, chrome plating, to DuroProtect 5 with a ceramic housing. The housing is coated with 100, 200 or 400 microns up to here, and the rotor is also from the execution DuroProtect 3 also chrome plated. Rotor is closed, C rotor for closed rotor, and the last one we get a rotor with DuroCard. This means welded with tungsten carbide. For these different kind of products, you need different kind of ear protection, but also for one product, you need different types. For example, we have a pressureless discharge for cement. It's enough the execution DuroProtect 3. This means chrome plated housing, 200 microns, rotor is chrome plated, that's enough. But if you have a conveying pressure about 0.8 bar, then you need the highest execution with the ceramic housing and the tungsten carbide welded rotor. The problem is the leakage gas and the expansion of the rotor. Here it's shown the rotor, the closed rotor. Starting with the DuroProtect 3, the surfaces on the top and the tips and the outside are chrome plated. The shaft also. You have also leakage gas without product, without running. Dust is everywhere, and the dust is going up to the rotary valve, and you get the wear on the shaft. That's the reason also protected. Higher execution. Everything is welded tungsten carbide, and the outside, like here, is also chrome plated. This is for higher pressure for these applications for long distance conveying systems. And here we see the housing. It's completely with ceramic covered inside. It's glued in. Limitation of the temperature is about 150 degrees Celsius. The reason is the glue. It's glued in, and more temperature high temperature is not possible. In special cases, if it's necessary, very high wind protection, for higher temperature we can deliver also the housing tungsten carbide sprayed. Here are the components for the application in the mineral industry. We have this drop through valve, product on the top in, on the bottom out, for discharge only, or for pneumatic conveying with a feeding tube under the rotary valve. On the right side, it's a blow-through valve. This means on the side plate are It's the channel, the conveying line connected, clean gas side and product side. This application is for higher pressure for up to 2 bars. If you use drop-through valve, there is a problem to get this chamber of the rotor empty because of the high pressure. The product didn't fall out completely. Also, the water valves with rear protection. The red one is also ceramic ring. This is diverter valve only, and the other one you can use it as a diverter and a collector. You can use it in both directions. On this side we have different executions. Standard is stainless steel, and then we get hardened pipes. We get pipes also welded tungsten carbide for the highest rear protection. Another advantage is this the part inside the rotor. It's symmetric. You can turn it around, so you have the used channel from the diverted pipe as a straight channel. So we have a double lifetime for this. Here's some pictures for this rotary valve. This was a big one. The diameter is 800 millimeters. On the left side, you see the rotor, also welded tungsten carbide, but machined, finished for assembly. Here you see 2 housings, completely with ceramic. And on the right side, this housing is used for this way. On the right side, the product is coming down. There's usually no weir. On the left side, you get the weir. Here in the middle, it starts in the middle. And on the top, if the rotor opens on the top, and in this chamber is also the pressure from the bottom, and with the dust in it, then you get the weir on these different points, here in the middle and on the top. Then this is also the reason we covered the inlet on the empty side also with ceramic. On the left side, it's turning the other way. It's turning the left side down, and there is also a possibility for this protection strip on the inlet on the top to protect the ceramic. It's an extra. It's sometimes customers like to have the protection. Sometimes not. All executions of all rotor valves, drop through or blow through, we have different step of rear protection and also different sizes. So you can see the capacity for the density as a sample 1000 close to cement, and you can make for particle size 0.6 millimeter, you can reach up to 240 tons per hour. If the product is fine, about like cement, it's about 20% less. And also the steps for the sizes, you can see every application, the execution of the rotor valve itself and the size. It's specially designed for every application. Here it's shown the drop-through valve for the conveying with the feeding shoe. And on the right side, the blow-through valve. We have no compaction, desiccation of the bulk material. It's just blown away. It drops off and blown away. The rotary valves are also available as a protection system, flame-proof and shock resistant, according to Artex, especially for coal, for example, for freeze. Low rotation speed. Maximum gauge written about 30 RPMs. This is for the bigger ones. The smaller one can make about 50 RPMs. Faster make no sense because there's no time to fill up the rotor. You get a point, you get the limit of the capacity, and then if you go faster, the capacity is going down. Also, as told, custom size level of rear protection. This is the same, different products. For limestone, it's maximum DuroProtect 4, and for fly ash, cement, you can, or you must load of the highest rear protection using ceramic. Also, you have no pressure loss in the rotary valves. No means about 30 or 50 millibars. Screw pump had maybe 300 or 200 to 300 millibars. It's also you can reach with the same lower performance, higher conveying performance, because you don't lose the pressure. This is a sample in Italy. On the right side you see one of these big valves, diameter 800 millimeters. They take the screw pump out and the rotary valve, the feeding station in. You have some modifications for the clean gas side, and then blow it away to the destination, connected to the existing piping. You can see the green one is the motor for the rotary valve. It's about 5.5 kilowatts. And the red one is the motor of the screw pump. It's shown later, I think, 200 kilowatts per hour. Here's the picture again, and we have 200 kilowatts. So the customer changed his system in 2009, testing for 2 years. After that, he decided the second station will be also changed. He's happy with it, no problems. Successful operation, energy saving a lot, 5.5 kilowatts instead of 200 per hour. This is a plant in Germany for coal dust feeding. You have a silo on the top with two nozzles. In the past, 2 screw pumps and a rotary valve as an explosion area. They take the screw pump out and get the rotary valve explosion proof in. So we have only the motor of 1.5 kilowatts each rotary valve. These are other samples. Germany once again. Conveying pressure up to 0.9 bar. This is a drop-through valve, also existing piping. Execution DuroProtect 5. The size will be 550. This means the diameter is 550 millimeters. And they will change 4 stations of these feeding stations.
So from a return on investment point of view, calculation, we'll look at some realised projects again. So give you another reference, this is in the USA, project of cement. This one was 180 tons per hour with an existing conveying pressure of 1.8 bar using a screw pump. The screw pump had a 250 kilowatt motor, and we replaced this feeding device with a blow-through 600 diameter rotary valve, highest level of DuroProtect because of the high conveying pressure, with just only a 5.5 kilowatt motor. And this system ran roughly a maximum 8,000 hours per year. So you can see there again, minimal modifications on the installation, just a modification to the silo cone or to the input hopper, and then a rerouting of the clean air line using the existing blower, and then a simple connection of the convey line to the existing pipeline. So very simple, low cost installation with significant power saving. So just to run you through the calculations here, how the customer, what the customer realised. His screw pump roughly had an estimate of 20,000 euros maintenance cost per year. It operated 24 hours a day, 330 days a year, which equated to 7,920 hours of operation. We didn't take into account any labour costs associated with that maintenance or loss of production, because we wanted to make it purely an energy calculation. We can definitely guarantee a more smoother operation at long term. So there's additional cost savings to be had there. Every ton of cement you can make, not caused by downtime, is significant saving, but this is just an energy saving calculation. The screw pump had a 250 kilowatt motor, as we saw. We are using the existing blower, so there's no change in energy there. And we've got quite a conservative estimate on 8 cents per kilowatt hour. So using that information with our 5.5 kilowatt motor, our rough estimate of recommended spare parts of 10,000 euros, we then have an energy saving calculation just in 1 year of nearly 2 megawatts. And that equates at 8 cents per kilowatt hour to 155,000 euros saving. Plus the 10,000 in maintenance costs, spare parts, so a complete annual saving every year, £164,000. Now this was a 180 tonne an hour conveying system, a very big system, and the valve had an investment cost of 135,000 euros, highest level of DuroProtect. As I mentioned, the installation was very simple, 20,000 euros maximum. Total investment cost 155,000, so this system paid for itself in less than 1 year. And on top of that, you have obviously energy savings, green plant, less carbon footprint, and also a higher efficiency, more flexible, less downtime conveying system. Much more simple, less complex in operation, easy to maintain. What the customer said, existing arrangement and pipe route didn't change, just a small modification. Smooth operation without downtimes, and we like to work closely with our customers once this has been installed. So we don't just install and walk away. We make a close relationship over 6 months, 1 year, 2 years, 5 years. And we made an inspection of the rotary valve after 2,500 operating hours, and no major wear was detected at all. And then the customer then decided again in this application to replace the screw pump in his second line. Another case study, return on investment calculation, last one. This is a smaller system, maybe what a lot more people are more familiar with in Europe. 50 tonnes an hour of cement, original conveying pressure 1 bar, the 55 kilowatt screw pump. As it's 1 bar, we were able to use the drop-through type valve with a 2.2 kilowatt motor with an annual maximum running 6,000 hours. So again, we looked at the maintenance costs for spare parts of the screw pump. It was roughly 20 hours a day operating, 300 days a year, equated to 6,000 hours. Again, we didn't take into any labour costs or downtime costs losses in production. This is just an energy calculation using our 55 kilowatt, compared to the 55 kilowatt screw pump. We used the existing pipeline, existing blower, existing everything, changed the feeding device, again using an estimate of 8 cents per kilowatt hour, 2.2 kilowatt new drive, an estimate for spare parts. This is a much smaller valve, and you can see there an annual saving of 320,000 kilowatts per year, which equated to a 25,000 euro saving just on energy. So take into account downtime, loss of production, maximise cement plants. You add this to the better reliability, better availability, savings end up going through the roof. It's not shown on this graph. Investment was 48,000 euros. Installation was very, very simple, just a few pieces of pipework, 2,500 euros. Total investment cost 50,000 euros. It's considerably small investment really. This paid back in 18 months. Again, customer says existing arrangement, pipe route didn't change, just a minor modification, smooth operation without downtime. In this case, we reviewed it after 2,000 hours, and there was no measurable wear on the protected surfaces. So the customer had maintenance savings from downtime, from producing more material. And the key point to note with this system is, yes, it was a €50,000 investment, it paid back in 18 months, but the customer did install this in 2006, and he didn't replace the valve until 2017. So we had 10 years of savings. So, to summarise, the rotary valve can be used to be easily retrofitted in existing client systems, with minimal modifications, whether that's changing the pressure vessel, whether that's changing the screw pump. It has minimal headroom, small footprint, easy maintenance, simple operation. And we can do that retrofit very simply and quickly. If you have a complete new plant, or a new system, or a new mill, we can provide a complete system up to the silos, so we can provide pipework, diverter valves, filtration, the feeding device, the rotary valve, the blower, the clean air pipe, if necessary. But today we're focusing on the retrofit solution. It's ideal for process optimization, debottlenecking from production downtime, maximizing production. It's a fairly low capital cost investment, and because of the return on investment, it's often justified through maintenance budgets, not necessarily capex projects budgets. And as well as the energy savings that equate to cost savings, it's a greener, more energy efficient solution, a more flexible solution with a much lower carbon footprint. It also, what all cement producers are interested in, it significantly reduces the cost per tonne of cement produced. You can imagine from the raw material stage, you may have raw meal being conveyed in the process, you may have in a pneumatic transport system, you may then have the mill cement transported in another conveying system, and then that finished product transported on again to a road load out silo or a rail load out silo. So in theory, in the product's life cycle, you're influencing it 3 times. And finally, we have about 100, maybe more than 100 installed references for this type of application, swapping out old feeding devices, outdated feeding devices, and putting in more energy efficient new feeding devices in. And we have these installed in all major cement producers across the world, whether that be CIH, Lafarge, Holcim, Heidelberg, Cemex. We have installations in all these places, so often end users, the system integrators will be able to find somewhere in the world a case study, a reference where they can get hands-on direct feedback from the operators. And that brings us to a close.
Thank you very much indeed, gentlemen, for a very interesting presentation. And what I particularly like was the fully costed return on investment calculation, which is always greatly appreciated. Thank you. So you do have a few questions. The first one, can your pumps cope with GBFS, granulated glass furnace slag?
Yes, it's a common material for us. Recently in the UK, we've installed a valve for conveying GBS. That's no problem. We look at the material characteristics, we can do analysis in our lab, and then we can select the right valve for the application.
Okay. Is there any possibility that you could change your glue so that it could cope with higher temperatures?
I think
it's difficult. It's done by our supplier, which delivered our ceramic, and it's made in this workshop, and we finish it, machine it down. It will be, the surface will be also machined. We don't do it in our house, but it is possible. If it happens sometimes, one brick or slot breaks off, and then you can repair.
Okay, so the supplementary question here is, can the ceramic linings of the housing be replaced easily? And is it done on site or at a Coperion workshop?
Only in a workshop.
Yeah, we offer like a once you have a valve running in place, and if you decide to order a second one as a standby unit, for example, then we can offer like a return supply refurbishment, where you have one in operation, we send this one back, refurb it, this one then goes in operation, we send that back and refurb it. We offer a nice sort of service package for this. And just going back to the question about the glue in the ceramic is suitable up to 150 degrees Celsius. I think not many times we get asked to convey projects over 150 degrees.
Sometimes
Sometimes, but I think again there is a substitute for this. There is, as Klaus explained, the other types of wear technology we can introduce, the spray-on
spray, carbide spray.
And again, the level of wear protection is significantly influenced by the differential pressure and the pressure in the conveyor line. So it may be you have a high product temperature, but the differential pressure is maybe half a bar. And in that situation, you wouldn't use a ceramic valve anyway, so you wouldn't have to worry about the glue because there's a different alternative wear protection.
Okay. Final question. How are the units sealed externally? The shaft seals on a rotary valve can leak under pressure over time. Can these seals be replaced in situ?
Yes, it can be replaced. We use also a seal perch to protect the seals. It must run all the time. If there is product in the rotary valve, the seal perch must run. Keep the product away from the sealing.
Right.
And you can take the sealing out without take the whole valve out. It's possible, yes.
Okay. Any questions from the real world? Yes, please. Give us your name and company, please.
Laurie Evans, Jackson. What's the maximum line pressure that you would take these valves to?
The blow-through valves is maximum 2 bar.
2 bar.
And the drop-through valve is more or less 1 bar.
1 bar. Okay. Thank you.
Yes, please.
Prakash Kumar from Air Retrofit. What is the maximum temperature you have tried in the lab for tungsten carbide?
Once again, please.
What is the maximum temperature?
The maximum temperature is maximum high temperature execution size 630 is 450 degrees Celsius, but with ceramic only 150.
With the tungsten carbide?
450.
450.
Okay. Any other questions? In which case, let's join together and thank these gentlemen once again.